going to leave it on because it's warmer. If you're ready, sir. Over to you.
Ladies and gentlemen, in the name of the Academy of Medicine of Belgium, I'm very proud to welcome you here in our palace. I just will give a few words of introduction. The Palace of the Academies was built, in fact, from 1815 to 1828 by Willem of Orange. Willem of Orange was the King of Holland, and he was given the country that is now Belgium by the Congress of Vienna in November 1815. He was an extremely clever, young and performing king. In fact, the young Willem of Orange II is said by the Dutch people to be really the winner of the Waterloo battle. The Wellington, according to the to the UK people, claim that it's a British who won Waterloo, but the Dutch say no, it's not true. It's Willem of Orange. This person was full of intelligence. He was extremely well performing, but he had no charisma, no empathy, and no diplomacy. And it took only 15 years for the Belgians to start a rebellion and to split and to separate from Holland. And so you need to be intelligent, you mean to have a quite sound natural intelligence, but you need also to have additional human qualities such as diplomacy, charisma, and empathy. And today, it's again approximately the same problem. Many European citizens have lost confidence in their political governments, and you see progressively that populism and the Gilets jaunes in France and a lot of rebellion are starting everywhere because the people don't really understand what Europe can do for them. Today, we are not going to speak about natural intelligence, but about artificial intelligence. Gustave Monin and myself spent several years in Washington, D.C., not far from Langley, where you have the Center of Intelligence. It's the Center of Intelligence Agency, but it's not that kind of intelligence that you are going to mention. We are going to discuss about the complex artificial intelligence that probably doesn't take also not into account the social and the societal demands. And we are extremely happy to have distinguished speakers and intervenants, and I hope that you will be pleased to be hosted in this palace. This palace does not only accommodate the Academy of Medicine, the French, we are a federal country. I see Mr. Van Stert again, and I should say that this meeting is also organized under the frame of the Koninklijke Academie voor Geneeskunde van België, the Flemish part of the Belgian Academy of Medicine. And we are sister academies, and we are developing more and more close links in relations to the Federation of the European Academy of Medicine. And I wish that we have more and more links within the national federation, but also with FEAM. You know that we are close to Brussels European Commission, and the commissioners in Brussels, who will be again elected next May, have very little consideration for national academies and for any national organization. They want to have a dialogue, but only with European organizations. And therefore, the FEAM and the FEAM statements are quite important because they really do have an impact in Brussels. And whenever we meet and we quite go, it's easy, it's across the street. It's 200 meters and you are at the European Commission. But to have a very strong interaction and to be heard and listened, you must speak in the name of an European federation. And FEAM is giving us this floor, and therefore we are very happy to accommodate this session and many other sessions during this year and the next year. So I hope that everybody will have a pleasant afternoon. I just have to apologize. The heating system broke this today. It does not date since the time of William of Orange, but it broke, and fortunately I hope that you can accommodate. Thanks a lot.
Well, good afternoon, ladies and gentlemen. It's a great pleasure to be here. And Jean-Michel, thank you very much for your very warm introduction and information on this absolutely glorious building that we're very proud to be in today. Thank you. Thank you very much for hosting this. And Elizabeth Bohm and Tom Livermore are here from the UK Academy, and thank you for helping with the finance of this meeting. Now, it's a shame it's called artificial intelligence, and I don't know how that name was coined, but it's caught on and it won't be changed. It is artificial, but is it intelligent? And perhaps it should be computers in healthcare rather than artificial intelligence, but we may follow this theme from our distinguished panel, and thank you all very much for coming along to speak today. We had a symposium on artificial intelligence in London about 9 months ago, chaired by a physicist from Imperial College, a lot of chemists, a few clinicians, and Panasonic were very interested, of course, for obvious reasons. The chairman, this physicist, stood up and he looked around the room and he said, "I hope there are no radiologists here." And, people looked rather quizzical, and he said, "Because in 2 years, you won't have a job." And of course, that was taking it to an absolute extreme. But as a physicist and a mathematician, he could say that, because as far as he was concerned, X-rays would be, or radiographs would be transmitted across the world. Somebody would read them remotely and send the answer back, or a computer would read them remotely and send the answer back. And one of the questions I know that we will be looking at today will be just how the human-human interface works, in addition to the fantastic use of computers. Welcome to all the Forum members here. For those of you who don't quite understand Forum yet, Forum is an organisation run by FEAM. Members are invited to all of the meetings, and if they have a particular interest, they suggest to FEAM, "I want you to organise a symposium on this particular matter." And FEAM is very, very receptive of that. So we have about 80 members now of the Forum, and these are ascendingly growing from many disciplines, from industry, the EU Parliament, as Jean-Michel has said, are very interested to get advice from a group like this. So welcome everyone, and we look forward very much to seeing if we can change the name of artificial intelligence. So I'll hand over straight away now to Jackie Davis, who will moderate the meeting.
Thank you very much indeed, George. George Griffin there, ladies and gentlemen, President of FEAM. I'm reminded, Jean-Michel, when you were talking about the argument over who won Waterloo, you made me think about the current arguments over who's winning the Brexit negotiations. But I think he explains a lot about our nation, as you can tell from my accent, where I come from. So I'll be moderating our discussion this afternoon, and we're going to have the annual lecture, as we seek to answer the question, artificial intelligence in healthcare, are we ready? I'm then going to invite our distinguished panel to join us here on the stage, on the podium, for a totally interactive debate. I will have some questions for them, but then I will come out to all of you, not just for your questions, but we have a lot of expertise in this room, so if you have thoughts you would like to share with us or reactions to the debate, we look forward also to hearing from you in that light. But we're going to start, as I say, one housekeeping note before we start. The Twitter hashtag for the event is FEAM Forum, and we do hope you will use that hashtag to share with the outside world what you are hearing here. But can I be very old-fashioned and ask you, if you want to ask a question, could you please do it in the old-fashioned way? Raise your hand and I will come amongst you with the microphone. I prefer not to spend the entire event scrolling through my mobile phone. I'm old-fashioned enough to like to hear your voices. So, with that, let us move to the substance of our discussion. And as I say, we're going to first have the lecture to set the context for our discussion, and then we'll debate the issues with our panel. And to do that, I'm delighted to welcome Andrea Renda, who is Senior Research Fellow and Head of Global Governance, Regulation, Innovation and the Digital Economy at the Centre for European Policy Studies, better known in this town to everyone as CEPS. And he's also a member of the European Commission's high-level expert group on artificial intelligence. I think you may have even been meeting today. You're in mid-meeting. So thank you for leaving that meeting to join us. Hot off the presses, ladies and gentlemen, I give you Andrea Renda. Over to you, sir.
Thank you. Thank you, Jackie. Thank you, Jackie. Yeah, indeed, we are meeting today. The meeting is ongoing, and it's not an easy meeting. So if I had to judge from the meeting that we are having today, what should be the answer to that question? Is Europe ready? If the question is the European high-level expert group ready to deliver the ethics guidelines on artificial intelligence? The answer is probably no. But still, we will deliver them. We will deliver them within the next 48 hours to the Commission, and you will see the final result, which is something that should look similar to this, which I took from the meeting this morning. So it's the latest version. You should see that in early April, sometimes around the 9th of April, as far as I know. So, first of all, just to warn you, because what you are about to get is a speech, a lecture by someone who's not, let's say, well-versed in the medical knowledge, despite the fact of being the son of two neuroscientists. I also, because in order to avoid overlaps in careers that sometimes, especially in my home country, are very difficult to manage, I took a completely different direction. And basically what I was sit on today is an original background in academia, which is potentially the most useless, but not necessarily the one that will be replaced first. And these are both news that you should keep in mind. I'm originally an economist. So the first ones that should be replaced, but unfortunately this is not necessarily what's going to happen, right? On the radiologist, of course, I get back because we still see that the terms artificial intelligence are a bit of a strange combination of words. No one knows exactly why it became so pop over time, but most of the people that work in this field, also in policy terms, will tend to disagree that this is an accurate description of what we are dealing with here. So those people prefer the words machine learning, but of course machine learning also depicts and refers to one of the techniques that we are using today in the so-called artificial intelligence space. I'm actually going to broaden the picture for you a little bit in the coming minutes, because I don't believe AI alone is likely to solve most of the problems that we have. I think we need to rely on what we call the full technology stack of digital technologies that are emerging today. So that said, what I do is just a little mapping of, from a policy perspective, of what we think are the key problems that are emerging today that potentially AI and related technologies can contribute to solving. And then, of course, since you're the experts in this field, you'll tell me if I got it wrong or right, or if I missed something. I'm happy to take it to the debate in the panel afterwards. So, European specific, of course, since we're talking about Europe, one key feature is the demographics, of course, the aging population. We have a projection of the European population to slightly increase between now and, say, 2070, which are the latest projections that the European Commission has published. This slight increase would not necessarily mean that they will all be original Europeans. I think there will be a shrinking of the European population, but immigration will more than compensate that, up to a level of reaching 520 million people by 2070. At the same time, the aging population is such that the average age of the European will go from the current, let's say, 43 years up to 46, 47 years in the next 2 decades. And that also will come with a shrinking of the workforce, if you wish, that reverberates also on health staff shortage. I'm not referring necessarily only to the UK, but the UK is a place where the health staff shortage, also because of Brexit, will be a source of most concerns. The Nuffield Trust and others, they have estimated something like 100,000 jobs missing in the health sector in the UK. Other countries, of course, are less subject to the big shock of Brexit, but we will have a problem in health staff shortage over time. So potentially the job replacing effect of artificial intelligence, of which I'm happy to exchange views later, will also partly have a compensating effect for the lacking skills that we have in this sector. There's also an issue of trying to optimize the use of points of care. Also, the issue of accompanying people through their care period by having different places in which information is passed on, in which equipment is interoperable, in which data are exchanged properly. There is also an emerging concern that requires a focus on things that sometimes are less of a let's say, the focus for those of you that deal with the profession directly, but they are the focus of the ones that craft the policy, and in particular when we talk about the free flow of data and when we talk about the compatibility and interoperability of medical equipment. We are also having increased evidence of the waste of resources that exists in this field, also signified but not exclusively represented by the fact that, for example, pharmaceutical products are very often overprescribed or sometimes underprescribed, but there is an optimization space that there we could potentially be reaching. And there's also other trends that you know much better than I do, the rise in lifestyle diseases, that also as a percentage are becoming very, very prominent statistically. The shifting in viral disease patterns, which also comes from many, many other causes and factors, including environmental factors. For example, how specific disease are transmitted with the global warming changes with respect to what our models can predict only based on past data. And that is also an issue for artificial intelligence and machine learning, which typically bases predictions on past data. And there's also, of course, in terms of optimization in this field, an increased problem in the long diagnosis timelines, which I would reframe as a foregone opportunity, meaning that in principle, if you use artificial intelligence systems, you could actually potentially, and then if this means a loss of accuracy or not, I'm happy to discuss with you, with your inner knowledge, but one could dramatically shrink the time needed for a diagnosis and thereby saving lives and optimizing care. And there's also an issue that potentially access to healthcare is something that is very diverse around the globe and also within countries. And indeed, if you look at studies on access to healthcare, the clear problems that are emerging a little bit on the privatization of healthcare, but also on the different quality of services depending on the ability to pay of the patients. You have a problem in least developed countries, but you also have a problem in the poorest fractions of the proportions of the population in developed countries that are increasingly being exposed to this problem. Now, is AI going to solve all these problems? AI today, in principle, can do a couple of things. Big, but still a couple of things. One, I would say, but that's my own way of simplifying this very complex, let's say, field. One is optimization. And indeed, improving the matching of resources, the matching of demand and supply, tailoring the prescription of pharmaceuticals, and developing business models that to some extent reduce waste and optimize processes. This is something that AI can help with. The other one is prediction. And prediction is something that typically AI is very good at, provided that the data that the machines are fed with are good and unbiased and are representative of what's going to happen in the future, going back to what I was mentioning before. And that is something where most of the ethical problems also lie. I mean, in both areas, meaning optimizing is not necessarily the most reassuring word for a patient, right? Especially a patient that is not an average patient, a patient that has a rare disease or a rare combination of clinical conditions, typically might be in a situation in which a machine provides the perfect, let's say, diagnosis and prognosis for the average patient, the ones that fall in the long tail and not necessarily the most, let's say, privileged when it comes to using this sometimes very rough systems. There are ways around this, but I'm happy to discuss them. But say in both areas, I think we have clear problems, and this is why, again, the European Commission felt the need to create a panel, and it's not just the European Commission. Everywhere around the world there are panels that are discussing the issue of whether there should be enhanced attention for ethical criteria and principles in their operationalization into the various professions. So some people already talk about, don't be scared, I mean, all of you that are doctors, but some people already talk about a potential second oath, post-Hippocratic oath, if you wish, which is the data scientist oath that is spreading, if you wish, in the profession of the data scientists, because sometimes, the meeting of these two sensitivities and these two deontologies is not as easy as it might seem. Just going to give you one example of this. Forgive me for taking some deviations and detours every now and then. I don't like doing purely schematic presentations. I like to talk to you. So the issues, I'm also old-fashioned in this respect, if you wish. No webinar pre-recorded, let's say. I'm here, and I was shocked, for example, not necessarily because that the person was not good and qualified, but I was shocked in a recent conference organized by Microsoft on data science, because a very good and knowledgeable data scientist from Microsoft came in and explained how they're doing various things in data science and feeding algorithms with data, designing algorithms. And she said, we're very happy because recently we have fixed fairness. And I come from social sciences, so I know that if you are a philosopher or an ethicist or even a political scientist, you would never say such a thing, because we actually don't even agree on the definition of fairness. What she means is that in their quantitative fairness models, they have found a way to incorporate them fully in the design of an algorithm, that whatever the outcome is, procedurally, they think that fairness has been embedded. This doesn't mean that they will not go to court, or they will not produce unfair outcomes, or they will not exclude someone from a treatment that was highly deserving. All this is something that a data scientist sees procedurally ex ante and with no relationship to the external world and the impacts that this will create so far. And whereas, of course, the ones that are there on field working on the actual outcomes and impacts of these tools care very much about the impact on people. Now, having the meeting of these two types of approaches is really what is difficult, and what we see also in this very tiny group of 52 people. Sometimes I call them the 52 musketeers, just to show how complicated it's actually going to be they are represented in the high-level expert group. Now, this high-level expert group, of course, is all the various stakeholders represented within the 52. I am one of the, say, 10, 12 people who are independent, because I am an academic and I don't represent any specific interests. I only represent what I think. So, is AI going to solve all this? It might solve, to some extent, the health staff shortage. Certainly it's not going to solve the problem of the aging population, unless we ask AI to solve it, but we might not like the answer. AI, you just get rid of a quarter of the older people, and then you see that the aging population problem is solved. It's fixed, like fairness. And it might solve, to some extent, the optimization of bringing patients across different points of care. It might solve the waste of resources problem. It might not necessarily, if not through conversational bots, recommendation engines, and interfaces to end users, some of the problems of the rise in lifestyle diseases. The rest, I think, is going to be a bit complicated, maybe diagnosis timelines. But to me, I think AI is only a very tiny fraction of the answer to this problem. So what I'm going to present here for you is a much more complicated picture of this, where AI, you see, is a pervasive component that I put to the left. This we call the new emergent technology stack. And you see that at the bottom, that's potentially the most important development that we're actually going to witness in the coming decade, is the spread of connected things or cyber-physical objects. The Internet of Things is, I wouldn't dare to say that in the meeting of the AI experts, but I would actually believe that the Internet of Things is potentially an even more disruptive development in the way we do things and in the way healthcare will work in the future. A microprocessor producer that some of you would know, called ARM, one of the most famous ones. So don't take the figure that I'm going to give you at face value, because it comes from a producer in this field, but they expect that by 2035, the number of connected devices worldwide will be around the figure of 1 trillion. Today we are approximately in between 8 and 10 billion connected devices around the world. Most of them are smartphones. There are also wearables. There are also industrial devices in networks and in industrial plants that are connected. The first implementations of so-called Industry 4.0, cyber-physical objects as we call them, this is spreading already. But the advances in technology, in particular in nanotech, in miniaturization of technology, and so on, this is going to lead to an enormous increase in the number of devices that we will be, let's say, interacting with, or that in most cases will interact with each other. Now, what are these devices going to look like? Some of them are the smarter version of the devices that we use on a daily basis, but others will be things like smart pills, or implanted devices, or tinier versions of wearables, or straps that contain chips and that record our fundamentals, if you pass me the word. And this is actually going to give rise, and I'm going to get back to this in the coming minutes, to a whole new set of potential business models, we call them sometimes in social science, but ways of organizing healthcare, because these devices will be able to signal and convey information on a real-time basis on the condition of the patient, thereby signaling the need for an intervention anytime in real time without people having to go to the hospital to visit a doctor or to use other external devices intentionally to actually get some a sense of what their fundamentals look like or what specific values are looking like in their health conditions. So on top of this, the Internet of Things will mostly be related to the rest through a set of new connectivity solutions, 5G technologies. A lot of people will read in the newspapers today about our big European dilemma. Do we deploy 5G with Huawei or do we wait? Although the people, companies like Ericsson would say we're there too, but it's clear that the only real option for Europe to deploy 5G in the next few years is really to also rely on leading companies, then facing potential risks, regardless of whether they are well grounded or not. Then on top of this, the connectivity will lead you to the so-called internet infrastructure, be that public or private, and this leads to all the world of platforms, what we call there the open internet, but mostly platforms and applications and content and data. And as a potential detour from this, the possibility on top of the internet protocol to use distributed ledger technologies that offer an alternative solution to the storing of data, to the storing of transactions, to the keeping of health records, and so on. And these are possibilities on which I'm happy to discuss. They're not necessarily front and center applicable to the topic of today, but they will be complements to what we're working on. Now, AI works on all of this. It helps companies realize how to optimize their data centers and the environmental production already at the IoT connectivity level, and it goes all the way up to the end users, which are an important component of all this, in trying to trigger through a user interface healthier behavior, for example. Sometimes we use this term in public policy, nudging people towards healthier behaviors by representing maybe the longer term consequences of their actions, or recommending actions, or perhaps representing the first interface of the end user whenever end users need a medical check or has a question that needs to be addressed. So on all this stack will evolve over the coming years. So don't just think that AI will make further breakthroughs or will improve over time. We have to imagine AI in 5 to 10 years from now as something that is largely complemented by an enormous amount of things connected and computing capacity that skyrockets over time. So computing capacity is poised to skyrocket. The EU has a relatively good tradition in research of so-called high-performance computing in specific applications. The EU is potentially the bloc that is investing not only on the traditional, types of computing chips, so the evolution of what we call the CPU, but also on things like neuromorphic chips that are something that comes very close to applications in healthcare, and try not just to model the outcomes of an intelligent decision, but they also try to model the neurons and the synapses, the actual inner working of our brain, assuming that we know how it works. I'm happy to discuss that because you certainly know more than I do, and I've had my exposure to current neurosciences. So the idea is that the projection of computing capacity by 2025, some of these projections say that computers would reach the capacity of the human brain, not necessarily the ability of the human brain to perform all its functions. So there you see the 100 billion neurons tag, which is, as far as I know, potentially an exaggeration. But most of you will have 100 billion neurons. I probably have 85, 86. But that's just one example. I mean, only imagining how AI is likely to evolve over time and how AI is today and projecting into the future only gives us a very tiny, a very imperfect picture of how not only the world but healthcare in particular and the potential for healthcare will evolve over time. And that's why, I mean, we have the DG Connect represented. Marco, you will probably say, if needed, something about all the investment that the European and the attention the European Commission puts on 5G, Internet of Things, high-performance computing, and potentially regulating platforms and the free flow of data. So that said, I'm happy to take questions on all the other layers and potential breakthroughs on AI. What we see is AI, together with these technologies, bringing potentially an enormous promise. First of all, because there might be convergence between various blocks on healthcare as being a problem. The US, because the healthcare system is evidently broken. As someone that has been living in the US until a couple of years ago and teaching in one of the top medical, the university that has one of the top medical faculties in the world, I can testify that the healthcare system in the US needs a lot of artificial intelligence, potentially, but a specific type, and not necessarily a predominant and prominent AI system over human beings, like it currently seems to be evolving. I'm happy to go back to this later. China has a huge problem with healthcare as well, and the EU has also the aging society problem and a number of problems in the national healthcare systems. So this convergence is likely to bring in potentially more converging efforts also to try and solve these problems. On the areas where most of the promise is currently seen is on the real-time prevention, what we call sometimes nowcasting of diseases, and the more accurate monitoring and more real-time monitoring of the evolution of patients' conditions over time. This at the micro level, individual patient, but also at the macro level, for example, spread of diseases and epidemics, pandemics. Greater efficiency in healthcare delivery and reduced risk of overprescription of pharmaceuticals. This depends also on the mode of delivery and the mode of, let's say, performance of some of the therapeutic paths that are foreseen for patients. Greater effectiveness through what sometimes is called data-driven mass customization of therapies and drugs. Now, let me take a little break here, just to name one example, which I think is outside the pure healthcare, but I think it's potentially a blueprint for what I might see, I would forecast for the future of healthcare in the coming years, and then you tell me you're completely wrong, and then I'll take it because I don't pretend to know everything. But for example, in Japan, there is currently a company that sells tea bags. And that company has now started a pilot project in which it asks a number of consumers to swallow a smart pill and then to declare some of their preferences for taste on tea bags. And the pill then records a number of fundamentals in the body, and coupled with the preferences stated by the consumer, the company produces customized tea bags that are shipped onto to the consumer. Now, while this is potentially an experiment, and I know tea is very important in Japan in any case, this is also potentially one of the avenues that some of the experts see for healthcare in the future, where you can have a device that is resident directly in the patient and is able to provide the information that will be needed to customize care. And this also means that the future pills or the future drugs might not necessarily be blockbuster drugs. And just like we talk in Industry 4.0 about mass customization of products, we might be talking in the future about mass customization of drugs. So forget about the aspirin or the various drugs that have hit the market and sometimes we call blockbusters. From now on, the whole production of drugs will be much more granular, and the fact that some of this research will be performed in the US will make it, in my opinion, very close to what happens right now, where you have the distributed networks of pharmacies such as CVS or Walgreens or the others that are able to produce almost in real time the pills that are needed for you, because this is what your doctor, whether it is human or hopefully it's human, has prescribed to you. So real-time, real-life monitoring of impacts also in policy terms during the delivery phase of pharmaceutical products and therapies. Now, is this coming soon? Well, it depends very much on policy, it depends very much on technology, it depends very much on whether all the layers of that stack that I showed you before will be adequately nurtured and developed speedily over time. And the most important, and potentially the slowest, but the most important of that is the one on top, is the users, but also the practitioners, meaning where the skills will evolve in a way that makes this sustainable development in healthcare or not. Okay, now the risks are several. The first risk that I see is whether healthcare will develop in this direction for all or only for some. Meaning those technologies are costly, access to these technologies and the luxury of having a world-class treatment also through these technologies, but also through the human component, is something that will be extremely costly. And in my opinion, it will be much costlier than the next best alternative. Whereas the next best alternative is not the traditional doctor, but it's AI only. So I will call this in the next slide what I call the junk AI problem, where that's only my formulation because it comes from the junk food. People say the junk food is welcome only because the alternative is no food. In the case of junk AI, I see already the temptation for international organizations such as the World Bank or others to, for example, solve litigation and legal controversies in developing countries by just using very rough algorithms, maybe based on data from other countries, just because the alternative is having very long waiting times for solving a controversy, and so thereby what you do is something that is totally inaccurate, will sacrifice probably lives, and will probably go through a number of errors, false positives and false negatives. But technology is there, so let's deploy it. And this, I think, is the risk that access to these top-level technologies with the human component will only be a luxury that the few can afford, the happy few can afford. There will be certainly the risk of pressure on the welfare system because of the aging population and the potential job displacement that AI will bring in, and how do we solve that? But the moment we are starting building business models based on flows of information, such as smart pills with supercomputers, we also have the problem of potential access to that information and what we call body hacking or mind manipulation. And inevitably, and that's of course something that we see already today to some extent, the risk of massive privacy intrusions. If we don't have policies in place that govern the way in which the information that we produce will then flow on the web and will flow across players in the market. And we also have the issue of having to depend on a flow of information and a set of calculations that we are not necessarily fully able to control. I'm going to show this to you in a couple of minutes. There is, actually I do this now so I save time. Let me see if I can do this right away. Okay, there is a recognized trade-off in this market, in this domain, between the various techniques that you can use, the various learning techniques that you can use in AI, their accuracy, and their explainability, okay? Meaning, sometimes if you use, for example, deep learning or reinforcement learning methods, even the designer and the developer, those methods are not entirely able to explain how the system has reached a decision. So this is sometimes known as the black box problem in algorithms. If you want to have a very accurate algorithm, this is what the industry tells you today, you're going to have to sacrifice a little bit the explainability. So this, of course, you risk, as you can see, is that you'll be told to do things without knowing exactly why you're told to do things. And if you couple this with the fact that you get a sneaky sensation that your doctor doesn't even know why you've been told to do those things, I'm not sure that this improves on the, first of all, on the trust relationship between doctor and patient. And also, I'm not sure that this is something that we want that happen in these fields. So just to give you an example, some of the things that we have to deal with when we deal with the ethics guidelines is the idea of deciding, for example, whether in healthcare all algorithms will always be explainable, regardless of the fact that there is potentially an alternative that is maybe even more accurate, but will not be able to explain entirely or trace entirely in terms of how it reached the decision. Yeah, I'll speed up a bit. So loss of agency, loss of self-determination, understanding exactly the context in which we're told to do things, or understanding that there's a therapy going on inside of us, because smart pills can also release substances in the future, and not understanding what's going on makes us potentially very passive or very, partly participating actors in this field. Okay. So chunk AI problems I already mentioned. So I'll go a bit quicker there, but I mean the ethical aspects that we are trying to deal with in this document, that was the draft. The word draft in this has gone away because we're finalizing it now, is the issue of bias and discrimination, whereas, for example, predictions or recommendations coming out for machines or decisions sometimes are based on data that is biased or based on a design of the algorithm that is inherently biased, thereby sacrificing fundamental rights or discriminating specific groups. Efficiency or accuracy versus fairness versus explainability versus privacy in some cases. If you talk to data scientists today, they will tell you that they actually need the most accurate and detailed possible personal information in order to have their algorithms work accurately. And that is something that, especially in Europe, we might not necessarily want to allow. The inclusiveness, again, I mean, who's going to have access to these types of technologies? Loss of identity, agency, and self-determination. The issue of liability, who's liable for those decisions? And the issue of explainability. I'll get back to the liability and wrapping up, but this is a little bit the scheme that we're working on. It's a working scheme for the group that I did for the group. The final graph will look slightly different, a bit less detailed, but the issue, the way in which we're working is the following. We try to define a number of core ethical principles. You will see differences between the bioethical principles and these ones, and I'm happy to take questions on this. But these are fundamentally these four: respect for human autonomy, the prevention of harm, the principle of fairness, and the principle of explicability and responsibility. There's a fifth principle, which is basically introducing an element, a procedural element. The fact that ethics should be embedded in the development of AI from the very beginning and on a step-by-step basis. The people that have ever been exposed to agricultural policy would call it a from farm to fork approach. That's what we call it in agriculture. And here is from the lab, from the design of the algorithm up to the deployment and use. This principal process leads into a definition, which is a definition that we're currently giving as our aspirational goal for Europe, which is trustworthy AI. Now, trustworthy AI has three main components. You see these three arrows. One, of course, trustworthy AI has to be lawful. Has to comply with the law. Sometimes we tend to take it as for granted, but law includes also fundamental rights. Not all these are clearly specified in legislation. So the ones that deploy AI today, in the first place, they should know if they are on the lawful side or not. The second is ethical adherence, post-compliance with the law. There are a number of other things that a group like this might want to recommend, suggest, that be translated into policy in various ways. If you try to translate into policy all these requirements, you might be over-regulating the field, but some of these requirements, and depending on the sector, might have to be made mandatory. For example, the requirement of designing for all, or the requirement of trying to avoid distributional impacts when you deploy AI. These are not necessarily unlawful, that they don't make AI that don't comply with these requirements necessarily unlawful, but in specific sectors, public services, public administration, healthcare, even education, you might want to have that as a mandatory principle. And this is where the gray space becomes complicated. And there is an area of robustness, meaning in order to be trustworthy, AI has to be technically robust as well, so that there are no major malfunctionings that could have been avoided. So through an exemplification of critical concerns and good practices, we go into what's the real novelty of this document, which is a checklist that the ones that develop AI will need to follow. The ones that use AI or distribute and deploy AI will actually have to follow to some extent. And it goes through a number of areas that are related to those three concerns. So I think that's probably the first time that this architecture is being presented, but that's a matter of days. That's our working hypothesis. Principles, definitions, and a checklist, which will be then tested by practitioners, companies, industry people, data scientists over the coming months to see if it makes sense or not. So this is what you will find. A few things in terms of clarification. What we aim for in most cases... Yeah. I'm not very far from the end. So first, I mean, this comes from the White House, but it's been widely disseminated. What we know in healthcare in particular, here is the case of the identification of metastatic breast cancer. And we see that typically, and also replicating these experiments also in other types of diseases, typically the level of error of the AI systems originally was higher than the one of human beings, experienced human beings, but the combination of the two was the first best. Today we're starting to see cases in which machines are better than humans, but we don't see cases in which a machine is better than a machine plus a human, because machines err, but they err in very odd ways when they do that, and you need to have a human in the loop or a human potentially in control in order to ensure that you're not creating important damage there. It is more costly. It is more costly, but public policymakers will actually have to understand that humans are good at certain things that you see there. Robots and AI systems are good at other things. It's the combination of the two that really perfections leads to the optimal results there. So we'll see many things in the future. Certainly, machine interfaces for human. We'll see the smart pills already being deployed. Now, the two questions that I want to leave you with are, in particular, this particular one, but the other I'll go very, very, very quickly over, is whether in this field, as we move on developing ethics guidelines for trustworthy AI, we should keep healthcare to a higher standard than when we talk about AI deployed for, let's say, an industrial B2B system. And certainly the ethics principles will not need to be applied in all sectors in the same way. There will be a piloting phase in which I think we will need to understand whether healthcare deserves higher standards. I sense also in the group of experts that this will be the case, not only for healthcare, but healthcare is a typical example that comes to mind. There are many ways in which the EU policymakers could translate those stricter requirements into policy. It doesn't have to be a regulation that says from now on this is mandatory. The European Commission could actually try to create markets or create demand or reserve some space only for extremely trustworthy solutions in healthcare. For example, in public procurement, in saying when you procure healthcare system, related AI systems, you only procure the ones that really adhere to those standards. So that while in the other fields, non-adherent AI systems are still lawful, they will still be lawful in the healthcare system, but they will not have access to this big market. Or you could also mandate that these systems are designed for all and they have additional checks on a number of the potential ethical problems. And, or you can have enhanced ex-ante risk assessments plus a certification system that is mandated. And that is possible. If it is possible, whether it's desirable, this depends on really gauging market and societal impacts and doing a sort of a cost-benefit analysis or something slightly different as I leave you with in this field. Now, just for the sake of completeness, the high-level expert group will now go into a second part of our work, which is after the ethical principles, we have to give policy and investment recommendations. So the policy recommendations, already you see those 3 bullet points there are policies. So we're now actually going to discuss how you translate, in the various sectors, those ethical principles into concrete policies. And there will be a sliding scale of different policies in the different sectors. The final thing that I wanted to say, on top of the ones that we'll be discussing later, is the AI high-level expert group has been given a mandate to work on the competitiveness of EU in AI, and whether EU can lead on AI. And to me, this, allow me the bad quote from Kennedy, but it's a bit like asking yourself, what can Europe do for AI rather than the other way around? So I'm much more in favor of bringing this discussion, and I think we're doing a little bit of that, and asking ourselves, is AI a means to an end, and what's the end? And here I've put the Sustainable Development Goals, the Europe Agenda 2030, which talks about investing in human capital, reducing inequality, reducing the gender gap, eradicating poverty, and in particular securing full and decent employment by 2030. So asking yourself the question whether there should be job displacement or not under this lens is completely different than asking yourself this question under a GDP, let's say, competitiveness lens. So, is Europe ready? Not there yet, but AI is not the biggest problem. Data availability will be a key issue. 5G deployment is still a big question mark. Ethics alignment is still underway and requires the input of people like you. And whether we will have something massive and very important at the EU level that really helps us tackle the healthcare issue front and center or not is also a question mark. I'll leave you with a footnote there. The Horizon Europe program, which has still been discussed in the European Parliament, potentially will come with a number of so-called missions. And I'm part of also the high-level group that advises Carlos Moedas on mission-oriented innovation policy. Now, some of these missions are healthcare related. There will be 2 or 3 that start in 2021. They're still being decided. But there might be, for example, a mission on reducing the burden of dementia. There might be a mission on cancer. These are being discussed. And I'm happy to tackle this because this will be an element also in terms of money or consultation and coordination of research efforts towards tackling problems. And I think that it's not just the ethics alignment, but to make Europe ready for the various challenges that healthcare will have over the coming years, it probably needs to mobilize all the different communities, including this one, where we're currently standing and sitting, and the research and the investment efforts in order to make this a priority for Europe. Thank you very much.
Very much indeed, Andrea. Thank you. Comfortable. So, thank you very much. Very comprehensive. Lots of thought-provoking questions there at the end, which I hope to address with our panel. So, thank you very much indeed. Let me immediately introduce the panel and ask you to come and join Andrea in the comfy seats. Gustav Moonen, who is Professor Emeritus of Neurology at the University of Liège and a member of the Belgian Royal Academy of Medicine. A very warm welcome to you, Gustav. Nicola Perrin, Head of Data for Science and Health at the Wellcome Trust. She's been leading on this area for the Trust and also led an independent patient data task force. So great to have you with us. Marco Marcella, who is Head of Unit for eHealth, Wellbeing and Ageing in the Directorate General for Communication Networks, Content and Technology, better known in this town as Connect, in the European Commission. I know, but I always like to spell it out and not assume that everybody knows what they stand for. Martha de Cunha Maroff Bergman, Quality Regulatory Affairs Program Manager for Radio Frequencies and Cybersecurity at Medtronic Waffen Research Centre, and she represents her organisation in MedTech Europe, the trade association for the medical technology industries, and last but not least, Stefan Platz, Senior Vice President, Drug Safety and Metabolism within AstraZeneca's Innovative Medicines and Early Development Unit. A very warm welcome to you all. So, as I said earlier, I've asked our panel not to make opening statements. We're just going to dive in. We have a lot to discuss, so I'm going to ask them some questions first, and then I will open it up to the room panel. There are 3 microphones for you to share amongst yourselves. So in answer to that crucial question of, is Europe ready? Andrea's answer was not there yet. But in terms also of its potential, I was interested. People talk, you don't need to do anything, they're on. In terms of its potential, you played it down, really. Normally when I do moderate a lot of events on artificial intelligence in lots of sectors, and usually this is the thing that's going to change everything. But you said it's a fraction of the answer. Has enormous promise, but only a fraction of the answer. I wonder if our panel agree. Gustav, from your perspective, how would you assess the impact that artificial intelligence is having now and is likely to have in the future. Do you agree with Andrea's analysis?
Partly. I think IA is already very present on the scene, but this is nothing as compared to what's going to happen in the next decades. So we are really in the early beginning. I'm talking as a clinician, but I'm not a radiologist. Okay? So I'm not protected by WWF. My concern is, are we moving to doctorless medicine as we are moving to driverless cars? That is, will medicine be just computers and paramedics and no doctors anymore? And that's the extreme. No one would agree with that, and I don't agree with that, but still, some of the people building IA are thinking that, and I think that the danger is that we lose empathy, we lose sympathy, we lose whatever that human aspect of practicing medicine. And one major thing is that currently we are doing and practicing medicine with a lot of black boxes. I agree. There are many things that we do not know. Still, we will have to teach our students how to deal with machine and black boxes. That the conclusion coming from machines that they do not understand. They do not understand why the machine came to that conclusion. More layers you have in a neural network, less the builder of the neural network understands the conclusion of the network. So that's something that we will have to learn and teach how to live with.
And that issue of education, training and skills, and also patient skills, for patients to understand how their data is being used, how artificial intelligence is going to be used. I'd like to come back to that in our discussion. So some major challenges there, and we already come back to where the machine goes back to your radiologist, George, and is there any radiologists in the room? Are you going to be out of a job? That relationship between the two, and you touched on it earlier and said you'll never get better than both. But is there a risk that we may begin to try it with the other way? Nicola, from your perspective, how do you see the impact of AI? How big a difference is it making? Could it make in the future, do you think?
I think it's one of those things that we tend to overestimate the impact in the short term and radically underestimate the impact in the long term. And you can think of lots of other examples of new technologies where exactly that's applied. I think it clearly will have a big impact, but in relation to this conversation about the role of doctors and radiologists, I think AI isn't going to replace doctors, but doctors using AI will replace those doctors who don't. And I think that equally applies to radiology as well, and I think it's a really helpful way of looking at it, because we need to think how AI can complement the role of the doctor and make doctors more effective in their relationship with the patient, and take away some of the sort of more burdensome, boring, routine parts of the job. And I think that's why the image analysis area is going to be the first that we really see a significant impact, but then over time it will increasingly come through clinical decision support tools, through self-management of conditions, and also some of the operational efficiencies.
Why do you say you think at the moment we're overestimating it in the short term? Have we not really understood the scale of the challenge to use it properly? And conversely, if we're underestimating it in the long term, why are we doing that?
I think you're right. I think it's underestimating the difficulties of getting this right at the moment, and it comes back to that availability and accessibility of the data, and particularly the quality of the data. And there's a huge amount of work that I think we've seen it with a few quick wins, and the DeepMind Smallfield example, where DeepMind have trained an algorithm to identify eye disease more rapidly from retinal images. The algorithm can now identify 50 eye diseases more quickly and more accurately than an ophthalmologist. It's just going into clinical trials now, but it's quite a clean, tidy data set. Even then it took 18 months to prepare the data and about a day to run the algorithm on it. The AI isn't the limiting factor, it's the data, and then also workforce issues, which I'm sure we'll come
back to later on. Thank you very much. Marco, from your perspective, a tiny fraction of the answer, an enormous part of the answer. How do you see the impact of AI and whether we are ready now?
Well, certainly we are investing in these two directions. One is to support the research and investment, so in coming technologies that actually improve over time. But we're also looking at the ethical and legal issues that are attached to it. So actually, it's quite a well-balanced approach to the area. And let me join my colleagues here. I don't think that the discussion is whether at the moment this will actually be heading today. There is no doubt that this technology will actually enhance, and that's the narrative that we're using. It is enhance, not perfection. So let me say there are 2 or 3 dimensions which are very important. We touched upon that today. So first of all, it is about data. Now it would be very interesting, perhaps with Andrea we can do one day this, to go back and reanalyze the evolutions of AI from who invented that word, or about neuronic equations in '66, and what we are doing today. But what is clear is that over the years, the situations in the availability of data and the ability to compute that data has changed radically. And that is what is making the difference. So it was impossible 20 years ago to think that one would train, sorry if I'm getting technical, a neural network with 156 layers. For those who know what I'm talking about, this would just be impossible. So it would take ages. So no one would engage into that. Today this is possible with a fraction of time. So what happens eventually is that if you have quality data sets, you can actually use these things to make inferences. Now, what we hear today is that, yeah, good, so we have the data, we need to have the capacity of managing that data properly with computing powers. We have the capacity to distill whether the quality, whether what we are using to train the artificial intelligence systems can actually lead to good results. So we have this framework in place. You see the connectivity that is important. So what are the elements that we believe are important to progress and get to the overall visions of, let's say, using to enhance that automation? First, that you will need the possibilities to deal with data from the citizens, from real case, that are meaningful to train the system. So you will need to have access to health data that is personal, that is sensitive. So you will need, together with this, the right and appropriate regulatory framework that actually permits people to engage with these technologies. Second, you will need to have an infrastructure that enables you to analyze how AI and the architectures that we have today are progressing the profession per se. We will need to understand how do we put together the legal and the ethical framework. You see, the explainability is one of those that emerges every now and then, because there is an issue. We have changed the paradigm of artificial intelligence. Before, we were modeling the doctor knowledge by putting rules. If this, then this. If this, then that. And it didn't fly. It didn't fly. The expert systems approach years ago reached the apex, because then everybody was looking for, what is the problem there. So today we have this. We have the possibilities to have access to quality data, and then we take the other component, which is about skills. Having that, it's a new technology that, it's similar to others, but it will change the way in which we operate. So you will need to have the people adopting that, so adapting the cultures and the skills.
Well, to come back on that, as you said, cultural question as well as a skills question. Martha, from your perspective, would you agree with the assessment so far, both in terms of the impact of AI, but also we're beginning now to enumerate some of those challenges that we face? How do you see it?
Well, I think that we are in a good path. Yeah. Artificial intelligence is progressing from the ethical point of view. The European Commission is working on that, and we have this high-level expert group that are doing well. Representing MedTech, I can see that we have the time to evaluate that ethics draft, and we accompany the effort that the European Commission is doing. Technically, artificial intelligence as well is evolving. There are new technologies that help to understand what we can do with artificial intelligence. And we can do a lot. We can help to diagnose. We can help to diagnose with computed imaging, for example. We can help with genomics. We can help with diabetics in terms of determining if a patient will have macular edema, for example, and the technology is there, and Roche has showed that recently. And we can help as well to create a culture that artificial intelligence is not really bad thing, but it's a good thing that will help the society in order to concentrate the focus on what is really critical. In the healthcare sector, what is really critical is to take care of the patient. So when the doctor has a lot of time in order to diagnose, but they cannot take care of the psychological care of the patient when it's transiting for a very hard period of time with their diseases, so the doctor can take care really of the patient in the overall and holistic condition. But artificial intelligence can help to put down those barriers of timing that the doctors need and to take care of the patient, because the artificial intelligence will help the doctors to do the job in less time. So diagnosis is fundamental in less time than the doctors are doing now. So artificial intelligence, robotics, data mining, the data science in general will help to evolve the technology for healthcare services, and will help as well to evolve the society with new concepts, with new paradigms of ethical conditions and respect for the human being.
So very far-reaching in the long term, and as Nicola indicated, a risk that we underestimate how much all of these things will change. The question really is, what's the path to get us from here to there, which I'd like to come back to. Stefan, complete the picture for us in terms of your assessment of the potential impact of this and whether we are ready now.
So, taking the entire journey from drug discovery to post-marketing, following up with patients, I think one needs to be very selective where to start. We will have areas where we today already see the value. We have saved last year about 30 million just by optimizing the supply chain. We're using AI in a very simple way of making sure that the 1,600 clinical centers we have around the world get the drug supplied in the most ideal way. It's saving us, I think, a huge amount of money. Another very, very important area where we can see an impact already is how we optimize drugs. So we have lead identification and there's a lead structure. We kind of run that through our 1.5 million compound library, and we can use AI today, we published on it, how we optimize drugs and find new compounds out of a complete different lead series that have properties and probably are not covered by patents to our competitors. So these are real examples I would like to bring forward. We heard a lot about imaging. It was interesting to see the quote from Andrea where he said 2016. I have seen something published 2018, and now the AI is ahead of the pathologist. So here I would really go for the question, will it not be only the pathologist, will it be the radiologist only, or will it be also the pathologist that's going to be replaced and reading images? But these are really, really examples they work with. Now, there are some more challenging aspects to it. Predicting patient outcome. Here you really have to deal with tons of data, real-world evidence data. Here the challenge starts, how do we know that the data we get are consistent in quality? How do we kind of build a database that is not biased towards certain disease, minimizing the risk of overfitting? Because you have a test set, you have a validation set, and it just isn't the right mix of control data. You don't put enough negative data in there. And the quality data we heard is really kind of questionable. Here I think there's a lot we can do, and we heard that from all the other presenters before, on the quality of the data, the ethics of the data, how data becomes accessible. So you can see immediate, tangible, measurable results today, some really kind of fantastic promises, but not easy to achieve.
Can I just pick up immediately, and with you first, Stefan, on a question that Andrea raised at the end when he talked about, and he was referring there specifically to ethics, but I'm also thinking more broadly about some of the other issues which we haven't talked about yet in detail, but the liability questions and so on. Do you think that the health sector, to use your phrase, Andrea, should be held to a higher standard because of its nature? Do you think these issues are similar to the sort of debates that other sectors are having about artificial intelligence, or is there something that is different about health and therefore will require different and very specific answers?
So, first of all, if you compare it to other sector, health sector, the data we deal with are multidimensional. So, if you go in an insurance company, a banking sector, you have a number, you have a firm number. Here in health, you deal with genomics data, patient records, individual data, blood pressure. That's a huge, huge challenge. And then, personally, health affects you in a different way than it affects you whether you have to pay back your mortgage. If you're a cancer patient, you want to have not just a vague kind of interpretation whether medicine works for you, you want to be more confident in the data you get back. So I think there is a higher ethical standard to be applied in the healthcare.
Would others agree with that? Please, Marco.
Yes, actually we are very much looking forward to the publications of the ethical guidelines, because then the next step is to see how this is actually metabolized by the constituencies, and there will be differences. I mean, of course, I think the building on what you were just saying, let's say driving an autonomous car may have completely different set of paradigms, but the concept that you mentioned before, like autonomy, like prevention of harm, the fairness or the responsibilities, they will be applied in healthcare, and it would be good to understand how the constituency take forward this concept and actually define them. So then perhaps in a couple of months, or more than months, we will see this discussion will have other effects.
Andrea, is it, I mean, the answer that you raised the question, what is your answer to that? Do you feel that health is different for the reasons we've heard and therefore it needs to be treated differently?
Yeah, my impression is that the reflection on the ethics of artificial intelligence should lead all the players in the space to perform risk assessment of what they're doing. And risk assessment, of course, is an exercise in proportionality, meaning you invest more in safeguards depending on the type of risk and the extent of the risk that is at stake. And in my opinion, as was said already, I mean, we're talking here about health risks, in most cases are much more important than simply having, however important your mortgage refused, whether your mortgage loan refused. And that said, I think this raises a number of challenges, of course, because this might mean that the market becomes a bit more regulated. So there will be resistance on the side of the industry because the regulatory costs might increase. There will be a second thing that I see, which is the combining the acceptability of the technology with the statistics. You could say, for example, we're having this debate today. The Ethiopian airline, Boeing 737 MAX, is an example to the extent that we're gathering knowledge of a machine that decides one thing, and there's no way that the pilot can change the direction of the machine. The pilot tries 36 times to change the course of history, but the machine prevails. Okay? Then they will tell you, these systems are actually saving a lot of other accidents from happening. The same is for driverless cars, the accident in Tempe, Arizona last year. But the social acceptability of something like this happening is very low, and I think we need to do this. Third thing that I think is important, Nicola might want to comment on this because the Wellcome Trust has done a lot of work on this, is regulation has to become more experimental and flexible over time to see to what extent we have to raise the standard. And so things like adaptive regulation and experimental regulation will become extremely important in order to see what's the right height of the standard in this respect.
Did you want to pick up on that?
Yeah, I think it raises some really interesting questions about whether or not we're holding algorithms to higher standards than humans. So we've heard that over time we're now getting more accurate results from a computer or AI than a pathologist or a radiologist, and yet we're thinking about regulating them in very different ways. And I think that raises really interesting questions, and one of the reasons that it is interesting is because what's the difference between a human decision and an algorithm decision? And the black box bit definitely exacerbates our concerns. But if you think about a committee of people reaching a conclusion in a closed room, is that also a black box? Probably not, because the difference is each of those people are accountable afterwards, whereas it's the lack of accountability with a computer potentially that is changing the way that we think about it. And then finally, sort of picking up on your bit about emerging technologies, I think the other piece that we're going to have to think really carefully about when regulating AI in healthcare is we're looking at learning systems. So do we think of this like a one-off driving test where we're testing something once, or is it more like the ongoing qualifications that doctors have where you want to know that they're still up to speed and performing right over time? And so I think that will put a different dimension on the way that we think about the regulation in this space.
Gustav, can I ask, in terms of the key challenges, do you see, we've focused a lot already on the ethical questions here, but there are, and they've been mentioned, other challenges in this area relating to liability, but also relating to things like infrastructure, the quality of the data and so on. What do you see as the biggest challenges if we are to make full use of this enormous promise?
Well, knowing that AI will address both at the public health, the population, and the individual patient, you have two things. My first concern is the validity of data. Let's take an example. If you bring data from electronic health record, we'll have to change dramatically for that. If you bring data from electronic health record, you have data from an over-sick population, because healthy people have no electronic health record.
Right.
If you bring data from people who wear devices such watch, I have a Fitbit watch. I mean, those people who have such devices and wear such devices might be over healthy and over wealthy.
They're the sort of people who buy these things, yeah.
And it's not a good population as well. So at the end, I believe that the system will have to be peer reviewed to some access. So my first concern is the peer review. Who is going to do the peer review of the system? When you reach a conclusion, whether it's valid or not. And then you need doctors. And my second concern is that it should be open access. Pretty much like literature right now. Otherwise you will have a system which will be sold by big companies, GAFAM or whatever, and most of the people will have no access to that. So we have to have good data, including environmental data, because in the etiology of disorders, you have genetics, you have environment. Where do you get, how do you characterize for a single person its environment? That's a major issue as well. And those are the data that need to feed the artificial intelligence algorithm. So I believe that there are, at the end it has to be peer reviewed, and we have already to design a system that allows to control that while doing elaboration and during use.
And is that beginning to happen already, or is that something that needs to happen?
It's not happening.
It's not happening.
No, I was wondering whether artificial intelligence could just learn ethics and modify ethics by learning. I mean, that's another issue regarding ethics.
In terms of the challenges, and we're adding now to the picture and the complexity, we talked about the risks earlier on. Martha, what do you see as the biggest challenge in this area? Is it the ethical questions? Is it some of these other issues that we're talking about? If we're really going to realise this potential and be ready?
Well, something that our colleague here mentioned is really important, the validation of the data, but the validation and the verification of the data. Currently, with manufacturers are living with the ASME, BMV 40 standard, and in the future will be more standards. But the standards on validation and verification of data are really important and critical. How we arrive to the outcomes based on the data, and we hope then not to have data biases, is critical. So the sensitivity of the AI systems is something that we need to take into account. So when we have 100% of validation verification, make a very sensitive system, but we need to know as well in those AI systems how the system arrives to the outcome. So for the healthcare sector is critical because we are dealing with human lives.
So do you believe, going back to that question from earlier, that healthcare has to be held to a higher standard?
Yes, we have high standards, and that's why we comply with the many standards worldwide, international and harmonized standards worldwide. And we don't have problems in complying with the high standards. Yeah? But the crucial is that even having high standards, if we don't have curated data, so we will have problems to have real and good outcomes for the patient.
You want to come in, Stefan?
Yeah, I think we need to ask ourselves how we capture the data. I've been in Mount Sinai last year, and it was quite impressive what they're doing here because it's about early diagnosis. Costs in healthcare are that high because we quite often come with our diagnosis too late. If we can go much more into prevention, I think we can significantly reduce the costs. Now, in order to get there, we need to kind of get individuals to a point where we have better and earlier access to the data. So the example in Mount Sinai was, not only they have data access to all the patients coming in, but they also started with people coming in like at work. Like what a really fascinating idea was like, a number of us going to a gym regular basis. So instead of, you have your watch, you have your sensors, you kind of get your data online into a system, and it picks up whether there is some abnormality in there. And that immediately triggers something where something sticks out. Okay, your data are first of all captured by standardized systems. You get an early indicator whether there is a risk. I think that's another important part when we talk about capturing data that we have forgotten about.
Thank you very much. Anybody else in terms of any challenges that we haven't put on the table? Yeah.
If I may, I would like to link with the two aspects which have been mentioned today. One is that AI will certainly work for optimization together with diagnosis, but then you have these other aspects which is at the core of this, at the end of the day, a computer model. It's an analytical model. It's not an extraterrestrial solution that we are building. And it is about prediction. So what will actually makes a difference in an AI system is that there is this predictability, so and you can put a little bit of probability around it. Now, my question is, are we equipped now to work with predicted things which are predicted? So you have 60% of an answer. So what does this mean? So how do we take this into the equation, especially if this software and tools one day will have to transform the health and care system? So how do we equip that element, so the predictability, which by the way is very similar to genomics?
Andrea, you wanted to come in on that?
We have already applications of AI that try to do what I mentioned in a term before, nowcasting, or very, very early prevention. They have a couple of problems. And the first example that I can make is the example of predictive policing. Those tools that are used to tell the police in a number of cities in the US, now including in a number of European cities, where a crime is about to happen. So some people call them the minority report tools. So that the police troops can be sent there nearby so that they can intervene quicker. Seems like a magic trick, but indeed these are based on past data. So indeed those systems always send to the same, relatively dangerous ghetto, the police troops, and this sometimes exacerbates bias over time, meaning that you over-inspect specific areas and leave other areas out. And indeed, these systems are very path-dependent to a large extent. The second thing that I see is that you can build an extremely efficient and accurate system for predictions. But this in most cases requires extremely intrusive data collection. And we've had in Brussels, for example, the terrorist attacks in the airport. It is no mystery that by wiretapping all phone calls and using facial recognition and body recognition, we wouldn't be able to avoid those attacks, right? That's the case. I'm not going into political examples here. It's just a metaphor for early detection. Do we want that? Europe is in a challenging position exactly because we need to find a way to ensure the free flow of data without ensuring the free flow and the free market for personally identifiable data. Will we really live up to that challenge? I'm not sure. if Europe meets that challenge, it's going to be a major breakthrough in the way in which technology serves humanity.
Before I go out to the room, I wanted to ask an issue related, and I'm interested, you talked about it in your presentation, but the word has not been used since, and I'm quite surprised in enumerating the challenges, trust. Because in the Commission's communication last year on artificial intelligence, Vice President Ansip, for example, underlined, trust is a must, was the slogan, and you enumerated, Andrea, in your presentation some of those, what you see as the core elements of trustworthy AI. But I wanted to ask the rest of you, and you were talking about it's the law. I mean, you said it's the adherence beyond the law, and it's the robustness are the three key elements. But for the rest of you, and this also links to the question of doctorless medicine and all those things, what for you is the core challenge if we are to get this trustworthiness, not broadly for AI generally, but specifically in healthcare? Are there issues here that you might not have in other sectors? How do you see this challenge? Nicola, can I draw you in?
Yeah, I think it's an absolutely crucial part of it. And one of the things that surprises me slightly in the ethics framework is that there's no mention of public engagement and involving it. It's kind of moving on from human in the loop to society in the loop in a way, and so allowing people and publics and diverse groups to be part of co-creating what an acceptable system might look like. I think one of the challenges with this is the starting point is a very, very low awareness about how health data is used in general. And surveys in the UK suggest that about 4 out of 5 people have no idea what happens to their electronic health record or how it's used even for their own clinical care, let alone all the research purposes on top of that. So there's uncertainty about what happens to data, very little awareness of how it's used and why it's important, let alone some of the safeguards. And then you add AI on top of that, and that in itself, that phrase, conjures up all kinds of uncertainties, overhyping, risks, it's the end of the world, robots, it all comes together into a way that people just don't know what to make of it. Plus you add in companies as well and concerns around commercial exploitation, and it's sort of a perfect storm of concerns. And I think we have to work really hard to help to overcome that and to have much better conversations about how health data is used, but also helping give people that idea of agency and some control of decisions that you were picking up. I think that's so important.
It is interesting you said that about robots. I happened to see my GP this morning, and I said, this afternoon I'm moderating a conference on artificial intelligence. They said, so would you prefer to see a robot next time you come and see me? That was it, the instant reaction from a GP. And how they see it. So it's an interesting question. Marco, this question of trust, it's so central. Is it different for health, would you agree, than for other areas?
2 remarks. The first one, it would have been nice from your GP, which is when will they have access to that technology?
Yeah, exactly. It wasn't.
It's not just,
yeah. He just saw himself being replaced.
Because, narrative, certain times, narrative shapes reality. Yeah? So we need to be careful with the narratives as well. So, what is interesting is that in DigiConnect, e-health, well-being and aging, which is my unit, it's part of the directive, which is called Trust in the Digital Society. Yeah. And it does so for one specific reason. Because you need privacy by design system, you need security in these systems, and these elements are tackled from the legislative point of view, but also technological point of view in our directive altogether. And I want to give you an example. On the 6th of February this year, the Commission issued a recommendation on it's called the European EHR, so the Electronic Health Record Exchange Format. And the reasons for that is to help, let's say, if you want, empower the citizen to access their records across the repositories where this data is. So, if I am in another country and I need to an unplanned care, then I might need to have access to certain information from my physician. So, what the Commission did is the idea was to come up with a technical specification that would allow transfer of data or access to data in a barrier-free mechanism. Now, this was shaped in blocks, and the first block was all about principles of these transfers. And the principles of the transfers were citizen-centric, data privacy by design, security by design. Look at what happens when you implement the GDPR in the health sector. These are the building blocks. Because if there is no trust here in AI, in how the data is actually used and what happens once I provide my data to a third party. If there is no trust in what the AI can or cannot do, these systems will actually have serious issues to deliver on its potential. So this is the reason. So our approach is to put this in the same framework of trust, and it's not just a technical issue for a technology for the sake of technology's approach.
Yeah, well, it goes to that, is it a means to an end or an end to a means, as it were? Martha, you want to come in on this point?
Yes, I wanted to reinforce what he mentioned, because security is one important and critical issue as well. Why we need to preserve the patient of any malicious attack. Talking about cybersecurity, this is one of my expertise. But the security by design, which the medical device regulation tries to ensure that manufacturers comply with this, is simply to think and to put the patient as a center for the design of the device or software. But security by design implies human-centered design, implies that we need to take care of the security of the patient, the safety of the patient, and the security of the data of the patient. So data privacy protected by the GDPR, for example. But the technology as well, we need to take into account what kind of technology we are going to apply when we design a device. Talking with my scientist colleagues in my company, where we do ideation sessions for creating a new device, what we always ask is this technology applying, that we try to apply to the device, ensuring more layers of security in the device? Yeah. If it's not ensuring layers of security, we disregard them. So this is why we need to take a lot of in consideration human-centered design based on security, first of all, because it ensures the safety of the patient.
Thank you. And Stefan, at this point, whatever you wanted to say, but also can I ask in relation to drug discovery and acceptance of these new compounds, that trust issue, because we have it in other areas as well, how do you see this and how do we need to address it? Coming out to you.
So, I was just going to ask, so how do we kind of help people to have trust? We can set up all the frameworks and all works fine, but how do we really get into the heart of the people? Giving them a booklet doesn't probably help. Most of them won't even touch it. So I believe we need to do something where, for example, in Sweden we have set up the AI Innovation Center, where maybe we need to take a decentralized approach and bring somehow in communities a culture that helps people to build trust. We need to bring it close to the people. And that is really about the aspects about data privacy, confidentiality of data, trying to be transparent what happens with your data. I don't think we have done enough in that space.
Yeah, transparency absolutely central if people are to trust. So they understand and they know that you're open about it, but they also understand what they're being told, because that's the other issue. Gustav?
This is what I meant saying open access,
yes.
Transparency. Well, I believe that AI should not be trusted without being critical, because you should consider practice of medicine, diagnosis, treatment as an easy task. It's a very difficult task. So now you take data, but what do you do if experts disagree? What do you do if there is no gold standard? What do you do if there is no single good answer? I mean, those questions raised daily in medical practice. You are going to use data coming from medical practice. There are no answers. Maybe AI can contribute to give answers, but we have to be critical about what will be proposed. I mean, and in education, both of doctors and patients, it will be important to learn how to be critical.
Thank you. Andrea, you want to come in? Then I'm coming out to you.
Yeah, on this last thing, one of the risks that we need to avoid is what we call the de-skilling of doctors. And the other thing that I wanted to say is liability rules on the one hand and data sharing are both very important. Very quickly, open access is a very, very tricky policy. Open access also means that the GAFAM, or GAFTAM, or GAFA, or FANGs, depending on the acronym you want to use, will have access to exactly the only data that they don't have, and they use them to build models and services that no other company will be able to replicate. So unless you build in the system some form of data sharing obligation for the large players like Germany is doing, you will never get a hold of this problem, meaning you will not have open access at once and then transfer from the GAFAM to the smaller companies that you're also advocating. I think that's why most of the debate in public policy is not about fully open access, it's not about fully restricted access to data, but it's actually about building trusted data spaces. Like it's happening in the automotive sector, it's happening in other sectors, and in agriculture, it's happening, in healthcare, I see happening a pool of players sharing data in a way that is trusted also with public administration and with citizens, but not having fully disclosed access to all data because that is actually going to backfire. The on liability, I wanted to say one thing, which is actually, I will say, first-hand experience. If you live in the US and you go to a GP, and had that experience, meaning since I was still working in Brussels when I was teaching at Duke, I was flying back and forth, right? And one day I go to see my GP, the only time I've been in 3 years, because I was feeling a bit, a bit of fatigue. The guy looked like a human being, but he was not a human being in the end. I mean, he was a human being, but what he did was materially take my narration of my symptoms and put them into a machine. The machine got back with, since I was a very fast...
Sorry, he was tapping, I don't understand what you mean. You were talking
listening to me,
and he was tapping away?
Tapping away. And to say, okay, I've taken all the information. And then, of course, the machine said, oh, what kind of very fat health insurance I do have, but super rich. Okay, he prescribed, and he got me into some trouble personally at some point, because he prescribed me a sort of a long path of seeing from the gastroenterologist to the neurologist, just because I was feeling a bit, dizzy or a bit, not even, a bit tired. And the issue that I investigated a bit further is that deviating from what the machine tells you, if you don't get the liability rule right, the liability regime right, if you know as a GP that if you deviate from what the machine tells you, you're exposed to liability.
You're going to.
And if you stick to it, you're not. That's not the best way to build a human-machine relationship that is human-centric. It's actually machine-centric.
Yeah.
And this, in my opinion, is one of the challenges that we have. Build a liability regime that safeguards innovation, gets the most of the machines, at the same time avoids that machines take over.
Absolutely.
And humans become
Marco,
passive.
I think perhaps a reaction from you on that question before I go up to the room.
Yeah, I think I totally agree. That's why when I start with enhance and not taking over, I mean, this is the line to this. Okay, we need to understand exactly how that interaction between those who are using the AI and then take the benefits of it would work in the future. It's part of our common understanding. This is an evolving space.
Thank you very much. Any other comments to that before I go? Gustav, please.
Something that shouldn't happen, it's an ethical question, that the public system should not sell patients' data to private companies, which has happened already in several countries. So I think there is a huge problem there that health insurances or social security or the NHS regarding imaging just sold to companies the data coming from patients without patients even knowing it.
Even if it's anonymized, it shouldn't happen.
Even if it's anonymous, because the patient is the owner of his record, no one else. So he should know if something is translated for research or whatever. So I think there is an ethical issue there that has to be solved if we want to progress. We have to progress. A solution has to be found. But I don't see my social security system selling all the data from my family to Google, like Fitbit is selling the data to Apple.
Stefan, you want to come in?
Yeah, that brings right back to companies like Semaphore in the US. I think the US is already kind of probably a step ahead of what you described you don't want to happen, because quite often there are companies already being built, they are accessing the data. And what we need to not forget about the data is an isolated data point is of very limited value. And if you just collect private data, it doesn't connect the data. So someone needs to make the investment in annotating the data, building metadatabases, curating the data, and then the question is who's going to do that? And at the moment, I can tell you, when a pharma company, if we go and do that for our own data, it is going to cost us, I can tell you, Novartis probably was spending 200 million just to get going. We estimated that we would have to spend about 150 million in the next 3, 4, 5 years, only to make the data valuable and accessible. So it is a question I have to put back to you then, who is going to funnel that? Will the European Union take up and pick up the funding for making data accessible?
Yes, but then I can replay. The public system pays to get the data and has to pay to use the data at the end. So there's something wrong in the system. I mean, the social security system pays doctors or whatever and to get the data who are in the electronic health record. And if that reaches a private company that makes a device, whatever, then the public system has to pay to get the device.
So, Gustav, just to be clear, your issue here is with the payment for it, not the sharing of it per se.
If it is to be shared and with something clear in the relationship between the patient, the public system, and the company who makes the device or the algorithm or whatever, that's fine. But so far, it's not quite clear in my opinion.
Nicola, you wanted to come in on this point too, and then if you give me the mic, I'm going to go out to the room. Thank you.
I think it's a really difficult one to work out what this value of data is. I'm not sure issues of ownership is a helpful way of thinking about it, partly because you can have multiple copies of data, which means that property rights become very different, and also you can anonymise the data, you can have people adding value to data along the way. So I think an idea of rights and responsibilities is probably more helpful than ownership as such in contract law. But having said that, it's something that the NHS is definitely thinking very carefully about as to what the financial value of all the data that they hold is, and you need an almost case-by-case basis because the value is going to look very different if it's using the data to identify a biomarker than if it's to train an algorithm, something that can then be solved multiple times. But I think the important thing is ensuring that there is some return back to the NHS or the health system, and also making sure that there isn't exclusivity. So I think one has to recognise that other people will add value to the data with the curation and cleaning the data and data preparation and things, but it's making sure that there isn't exclusive access to that data, particularly if the data is being collected within the public sector, which comes back to your open access point. It may not be openly available to everybody, but it's available within a controlled way.
Thank you very much. Let's just go out. Yes, please, George.
Well, first of all, and fantastic, that's all I can say. We could be here for weeks discussing these things. Two comments I would make. The first thing is I'm really pleased that Andrea mentioned risk assessment, because in my field, which is infection, control of infection, treatment of serious infections, you always have to have what is the risk of what I am doing and what is the risk to the patient. And I think you're absolutely right that a risk assessment on all of these things you mentioned is done. The other thing with just Nicola's last comment, I mean, my general practice sells my data, I know, and I tell them not to. And the reason is because I don't know how valid those data are. And you know the old adage for computers, rubbish in is rubbish out. Yeah. Well, you know, even simple parameters like blood pressure are measured very poorly. You know, it's plus or minus 20%. Now, how that can be used...
So just to be clear, George, your objection is not to the selling of it, it's to the quality of it. It's okay to sell it?
Well, it's okay to sell it, providing there is the consent of the patient.
Yeah.
That's the first thing. But then my second point is you have to be very clear. And I mean, speaking as an experienced clinician and somebody who is a biomedical research scientist, you have to be sure of the validity of your data. And if you're not sure and you are making big conclusions on it, then that is quite clearly ridiculous. So I would say that. But the quality of the discussion is fantastic. I mean, how long have you got?
We've still got some time. We've got lots of things I want to ask still, but let's take a few more from the floor. Thank you.
So this is really wonderful. And
can you introduce yourself to those who don't know you?
So my name is Stefan Konstantinescu. I'm Vice President of the FEAM, and I'm a researcher here in Belgium at the University of Louvain, where I teach cell biology and I'm doing hematology. So I have two questions. One is, how can artificial intelligence improve the quality and filtering of the data that would fit into the artificial intelligence? So that is one. And the second is, I'm hearing a lot about this business that physicians will be replaced, that we will have a physician-less hospital, but I think that's really wrong. It will never happen. The point is, how can physicians get better because of artificial intelligence? So those are the two.
Absolutely. So we'll keep coming back to that skills question and how to make that human machine, that ideal situation of human machine really work well. Any other questions or comments to our panel at this point? Yes, please. Jean-Michel, thank you.
Just two questions. One is clearly about the accuracy, because it's very true that one mistake replicated 1,000,000 times makes 1,000,000 mistakes. You know perfectly the 1 million women study, and Valérie Perron, who created in UK, in the United Kingdom, which is big trial, 1 million women. She was challenged by many UK epidemiologists who said, you're just replicating 1,000,000 times the same mistake. And I don't know what the truth is, to tell you the reality, but the evidence-based medicine is based on observational studies or randomized clinical trials, and what you get out is just what you feed in. And again, the Women's Health Initiative in the United States has shown that after 25 years and billions of dollars spent, you get nothing. You get exactly the opposite of what was claimed for 20 years, and it's a big problem. So what you get out of your computer is what you feed in. First, that's the accuracy of the data. The second big question is, you know, you have hackers who are even able to enter the software of the Pentagon, and they can paralyze the system. It's not a big problem for healthcare because it won't last, but if you have hidden spy who can manipulate your data in a company, how can you trust the data that you generate without knowing if you're not contaminated by a virus that tricks your system? How will I? And for the military application, artificial intelligence is also a big. We were talking just about healthcare and civilian application, but for the military aspects and the defense of Europe against, let's say, not AI, but the EI, it's a different problem. So it's a little bit worrisome.
Thank you. Martha, could I ask you to pick up on that question about, because you are a cybersecurity expert in this area, the manipulation of data, that risk, and Jean-Michel's concerns. Can you pick up on that point? And then we'll come to this broader question, because I mentioned it. We talk about the quality of the data being a problem for AI, but George, you turned it on its head in a way by saying, how can AI help to improve the quality of the data? So how do we get a virtuous circle instead of a vicious one? But first, to Jean-Michel's point, if you would, Martha.
Yeah. I'm going to say something that many people can believe or not, but there are, you have heard about the white hats and black hats hackers, right? So the white hat hackers are really good people that are trying to help the healthcare industry or the manufacturers to find vulnerabilities in the devices in order to prevent malicious
before the bad guys do.
Before the bad guys do. So thanks God we have the white hat hackers that help us to identify vulnerabilities. But the vulnerabilities in the device doesn't mean that the device will be actually or practically hacked. Because there are many factors before a hack to that device can happen. First of all, a hacker needs to have very, very good access to the device, needs to have access to the code of the implantable device, for example, in the patient has. That may not be the case, yeah, because it's very difficult to have access to the special code of the device that is implanted in the patient. So many people don't know that. So the hacker needs to have, for example, the code of the peripheral device that is connected with an implantable device. If the hacker doesn't have the code of the implantable device, doesn't have the code of access of a peripheral device with the implantable, will never access that device. Will never access that device. So having vulnerabilities of the devices is good to know, but doesn't mean that the device will be attacked or will ever be attacked. And there are a lot of concerns about in population because of the media, about the cybersecurity or the security of the devices. But what we need to do as well as manufacturers, as industry in general, is to educate the people that not all that is, all the news around cybersecurity is true, but to tell them what is the truth of the devices.
Sure. Yeah, absolutely. Thank you very much. Thank you. Coming back on this question of the quality of the data and that sort of, if you like, as I said, turning it on its head, and also the point about replicating mistakes, which presumably becomes more of a risk in this situation, or not, I don't know. I'm not Nicola.
Picking up on the point about the role of AI for cleaning, that piece about cleaning and curating the data takes about 80% of the time at the moment, so it's a really, really important one to look at whether or not you can apply data engineering to it. Interestingly, until now, it's often been a really manual part of the process, in the same way that there are lots of call centres in India. In Africa now, you have banks and banks of people just sitting in front of computers labelling images to say if it's got a shop frontage or if it's got a cat or a dog, so that AI can then learn from it. Optum and Flatiron have hundreds of nurses labelling data all the time. So it has been very manual. I think there are massive opportunities to do more with AI and machine learning in this space. It's not well funded at all, partly because it's really complex, partly because there are more exciting opportunities nearer the healthcare clinical application end, and so it just doesn't get investment either from research funders or commercial investment. But I think the opportunities there, if there was investment, would be huge, because there are some tools that are very effective, but they're developed for one set of data in one institution and they're very rarely generalisable. And one of the key things will be to develop these tools in a way that they can be applied much more widely and available open source as well, so that anybody can use the tools and apply them to their data sets.
Any other comments to that before we come on to the skills issue?
So, yeah, I'd like to comment on that. We had a really interesting discussion with some of our scientists, because how much time do you want to really spend on, cleaning up all your old data? If you today, a lot of us as scientists, you repeat an in vitro experiment and you have a variation depending on the type, daytime, the weather, by 20%. So how you kind of baked it all in? The answer, but a number of people are saying, yeah, just about tons and tons of data. And then automatically all the data will get you kind of to a mean, and then you will be right. I was talking recently to somebody from Stanford, and she said, you know what, I don't care about the data. I generate those data in my own labs. I don't need that much data. But I have complete control about every single step in an experiment. And I can predict, with less data, but some sophisticated smart AI, I give you results that are better than if you throw a ton of data on some of your systems. So there is, in my opinion, not a clear answer.
Any other quick ones to that before we come on to the skills issue? Marco and then Andrea.
This is part of the research, where so actually, at least the Commission is actually investing significantly in developing the architectures and then the applications of use. And I think that your question, can we actually filter the data so that we know that the space that this has created is good or not for the predictability, is part of this, is integral part of that kind of developments in the AI. But I'd like to put on also, is that an application for dermatology or for cardiology may not be the same as for mental health. And if you look at the, let's say, cardiology, you can limit to the analysis of ECG, and so filtering that kind of data has an understanding. If you look, for instance, however, at analyzing huge amounts of electronic health records of a mental hospital, then our understanding of filtering may be different, because, for instance, the natural language processing tool can actually help us in dealing with the narrative produced by the doctors over time, which is a totally different problem in analyzing tissues, for instance, in pathology. So, but I think that is a part of the equation, especially when it comes to the analysis of the narrative produced by the doctor. So opening up the HR has also this effect. So developing that should be part of the research.
Quick one if you would, Andrea, because I want to come on to the skills question.
Just to say, if you want as a slogan to make it short, what you did with discovering over time is that there's a lot of people that say that data is the new oil, right? And most people start disagreeing with this. And also because AI has, there are many techniques of AI that are a bit less data hungry than the ones that we use today. And a recent conference actually changed the slogan and saying actually trust, I think, is the new oil. You can have less data, you can have well-curated data, well-collected data, you can have well-documented steps in the design, development, deployment of an AI system, and you probably do more justice to what AI can do to augment our intelligence than just going on into swaths of data, the origin of which is sometimes very difficult to trace, and the representativeness of which is also very difficult to trace, and the ability of this data to project us into the future in diagnosis and predictions is a bit less than when you use properly well-collected and curated data.
When we talked earlier about are we going to be in an era one day of doctorless medicine, and I think the general consensus is no, that is not where it's going, that's never where it will go. It'll be that perfect combination of machine and human that we get to. But I think it was you, Nicola, who said it's not about whether it's doctors or robots, it's about doctors who use AI and doctors who don't. If we are to make sure that our doctors can really realise its full potential and use it well, and don't get de-skilled, because I was interested, it sounds to me like, are we talking about new skills or the risk of being de-skilled by machines? How do you see this dilemma, first of all with the medical professionals, and then I'd like to come on to the patients and the same question about the skills that they need in this new world. In terms of doctors and making sure they have the skills that they need, are we doing enough? Has there been enough focus on it? And if not, who needs to do what to address this? Stefan.
I take my own personal example. So, how many of you are using OneNote? Okay. My PA said, Stefan, can you please use OneNote? Rather than walking around with his hand-scribbled notes. I was quite reluctant because it's a new system. It took me, after 6 months, and she persistently asking. I got to the stage where I then finally used OneNote. 6 months, with pressure. And I think we need to do much more in educating people. I have in my own organization mandated that everyone needs to go to a Spotify training. That's something very simple, but this is where we have to start. It starts all with educating people and training.
And there needs to be a mandatory element to it or it won't happen.
I think you have to.
Other thoughts? George, you want to go in? No, please do.
Thank you. I could just say one thing. It's not de-skilling, it's re-skilling.
Look at me, the risk is de-skilling.
So we're talking about a risk of de-skilling.
The risk is de-skilling, but I would say keep things the same for the baseline core requirements of being a clinical doctor, but re-skill in terms of the ability to let AI enable you to be a better doctor.
Gustav, with your students, the degree to which this is now part of medical training already, or not? Please, yes, sorry, we're trying to juggle with the mic.
Well, this is my major concern. We should introduce AI learning, understanding in medical education.
Yeah.
It's not done anywhere. And the skill, if you consider the single patient level, that is a doctor sees a patient and go and ask the computer to say what's the diagnosis and what's the treatment. The problem is that he needs to feed signs and symptoms. He needs the skill to collect signs and symptoms. And if you have listened to patients, they mix everything and you have to understand and transform their words into the clinical words and so on. And even examining a patient, at least in my domain, which is neurology, is not that straightforward as you think. So the clinical skill will be the key point to have the AI system be valid. And at the end, you end with an answer, and then you need common sense and science, whether that's true or not. So you need a doctor in the beginning, and you need a doctor at the end of the whole process, considering each patient. I'm not talking about public health, epidemiology or whatever. I'm considering just being a clinical doctor. You need the doctor to introduce the appropriate data And if you
know how
if you are wrong,
yeah.
you get a wrong answer,
yeah.
and you need a doctor at the end to see whether the answer is reasonable or not. And so there is no way WWF should protect doctors. I mean, you need doctors anyway, and you need doctors to explain the patient, and you need also to train the patient, and that's going to be another issue.
Yeah, we'll talk about training the patient in a moment, but Nicola, you wanted to come in.
Yeah, so I think there's two things that we have to think about. One is the example that you were giving with your doctor typing away, and at the moment the technology is moving the doctor away from the patient. You're hidden behind the screen and concentrating on what you're typing instead of the patient. So I think it's about helping the clinicians do their jobs as effectively as possible, which means understanding what the clinician needs and what would actually help them rather than what the designer thinks would help them. And I think the other thing, which is to some extent related to that, is thinking how clinicians, data scientists and biomedical researchers work together most effectively. And at the moment they talk three totally different languages. And so how do you bring them together in a way that they can collaborate effectively? Because the data scientists sort of coming from the tech sector mentality of move fast and break things, that as an approach just does not fit with the clinicians' approach, which is about fixing things and getting things better. It's a totally different mindset. And researchers are coming at it from a hypothesis-driven, here's our research question, and then sort of testing that question, whereas the data scientists, oh look, here's a massive lovely pile of data, let's talk through it and see what we can find, and there's some patterns in there. That's a very, very different language that they're both talking. So how can you bring all those different conversations together in a way that helps people collaborate more effectively and more quickly? And that has to be about getting people together to work on these problems.
And as Marco said earlier, it's cultural. It's a culture, and you need to...
Yes, and I note it down again. It's a matter of culture, so it is emerging as an issue. So this interaction between the human and the technology, now we want to call it AI, let's call it AI, but it is a part of the evolution. So, sorry, to be very open, I think that if you take an ECG system today, it already tells you whether there is an infarctus going on or not, but you don't question whether this is coming from an AI or from any analysis of the ECG, right? So, and this is part of the research. Now, if we put the AI into the equation, we're not saying here that we are transforming the doctor into the one who inputs the data, presses the button, and does what the system tells him.
Not like this guy who just said, oh, this is what it tells me.
That's not what we're saying. What we're saying is that if you take images, so take the radiologist, no? The one that you mentioned at the very beginning, this is the guy who's going to do so. Well, the analysis of textures over a Tesla 3 images that can be performed by high-performance computing is 1,000 times more than what the human can do. So we're not saying that this will actually replace, but rather help in analyzing huge amounts of data and images that we have to be confronted when it comes. So if you take a normal hospital, if I am not wrong, it's about 22 petabytes of images every year that you analyze. So, and it is in that perspective that we look at the enhancement of that specific data. Now, does this mean that when it comes to litigation, that component should be an integral part? So data science and AI should be part of the equation. We'll believe that that is, of course, this is another competence that is left to member states. But we believe that there is an impact.
But part of this reskilling challenge is that perception. I mentioned my own GP, whose reaction was immediately, you're talking about replacing me. That's what your conference is about. It's about...
So that's why I say, now that you sit and they have an effect on reality.
The willingness of medical professionals to reskill, never mind the young ones and whether it's part of their training, will depend on their perception, and they seem to have the same perception as the public at the moment, quite often. This is bad, this is going to replace me, this is not something I should be embracing, it's not something that helps me, it's something that... So how are we going to get, I think industry is in a different place and is moving forward. How do we address this and make sure that doctors themselves see it as an asset and not as a threat? Because I think
it would be nice to check here among these very educated audience how many people have actually used Google to do symptom checkers. That would be nice. And then check.
How many of you have been on Google either because you think you might have something, and I mean, I've been told again by my GP says I'm so tired of people coming to see me who tell me what's wrong with them. Because they've been on Google, put there, they say, well doctor, I've come to see you because what I'm sure I've got is X. How many of you Google your own symptoms? Almost everybody. How many of you, as I do, fiercely resist the temptation because you think you might read stuff that might frighten you unnecessarily? Yeah, that's me. I'm not going to read that. I'd rather talk to a human being who's going to tell me what I need to know rather than all sorts of strange. So that brings us to the patient. Because we're talking about also patient skills. Patient skills to understand, and it links to the ethical question. When we talked about this human, you talked about it, I think earlier, the patient-centric approach is absolutely central. Are we doing enough to make us as citizens, so we may not be patients now, but one day we will be, ready to understand how artificial intelligence is being used, and therefore ready to give our consent or not to the uses of our data? I mean, George, as he says, he's saying, no, you can't do that, and I'm telling you as a professional, but what about the issue, are we focusing enough on giving patients the skills they need in this brave new world? Martha?
Well, I think that the patient, I'm one of the patients that trust in the evidence. That means I'm not going to Google on symptoms. I will go to the doctor, do the analysis, blood test, etc., X-ray, whatever is necessary, and I will see the outcomes of the evidence. Yeah. So, and this is the scientific approach. But the patient needs to believe as well what artificial intelligence tools used in healthcare can benefit in the diagnosis of their disease, for example. They need to understand how even not only the patient, the doctors as well, how the artificial intelligence system came with the outcome. Yeah, so that's why AI needs to be understandable, explicable, and with created data.
But again, do we need to do more in the classroom, as it were? Is there enough attention to this? Not just in healthcare, but in all sorts of areas where AI is going to impact on us.
But you're talking about ideal patients. Real life is not that. I mean, there are patients, there are mothers who deny vaccination to their kids, and all the evidence, scientific evidence is clear. You need to be vaccinated against measles or polio or whatever. There are parents who reject that.
Yeah.
So don't think that patients are as educated as
you
or
as rational,
as evidence-based. I mean, you need to have some kind of interface between the diagnosis and the patient, and that's one of the main roles of the doctor.
Yeah, absolutely. Nicola, can I just come to you, because you led this task force, as I understand, and this was precisely about helping patients to understand how their data is used, what it's used for, and how. What did you learn from that task force work?
I think the key thing for us was to explain to people why data was being used. So we found that people generally, the more information they were given, the more comfortable and reassured they were that it was appropriate to use health data in this way. To the extent that by the end of a 4-day citizens jury or a 4-hour focus group, patients say, well, of course this should be happening, why isn't it happening?
Whereas they might start with a reluctance or reticence.
So they start with very, very low awareness, and just even a little bit of information suddenly raises all kinds of concerns and questions, and they actually get far more concerned with just a little bit of information. And then as you give more information, you get over that. And it's how to give that information in a way that's accessible, engaging, easy to understand, particularly when data is such a dry, technical, complex subject. So when we were talking about anonymisation, just the number of different words that there are to describe de-identified data, or pseudonymised or de-identified for limited disclosure, it's really, really complicated. And
I've never heard de-identified before.
Depersonalised, there's all kinds. We had a whole whiteboard of all the different kinds of words that people used, and actually what we found was the most effective way of doing it was with pictures. Pictures told 1,000 words, and you have a photo for somebody who's identifiable, you blur the photo for pseudonymised, de-identified, and then a group silhouette for aggregate level properly anonymous later.
And they began to see.
And they began to see it, and you get the idea that the more you blur the picture, the less easy it is to identify somebody, but equally that information becomes less useful to a researcher. You can do jigsaw re-identification with it, where you have different bits of the same picture and you can get identifiability. So I think there are ways of doing it that can be really simple, but you just have to start from a standpoint of people knowing very, very little about it. But it's also the same as with your mobile phone or your washing machine. You don't actually need to know how it works. You need to know the bit that you need to understand to use it properly.
But that is, when everyone has this conversation about, for example, the use of data, it always fascinates me that people are so willing to share on this, everything about themselves, and don't get hung up. And then you say, oh, now can we do it for medical purposes? There's a really interesting cultural, societal thing going on.
People see the benefit to themselves.
Because they understand it. Second, quick one if you would, because there's one issue I want to come to before we wrap up.
People are not patients. That's for me the big difference. If you're a cancer patient, I think we all have relatives, friends who have cancer and being diagnosed with cancer. If you can tell them, look, we're going to go for an individualized treatment, we can find a drug combination based on the data we have from you. That's very powerful. So you need to look at that, not from a population perspective, you need to look at the disease you suffer from and what is the benefit. I've rarely seen somebody who would then say, no, I don't want to do my genomic screen, no, I don't want to do that. Because we can give answers to you, what type of mutation you have, what might be the best treatment, and what gives you a longer survival.
There was one issue, before I try and draw some conclusions from this, I wanted to come back to Andrea. We've really touched a lot on the who needs to do what question. And Mark, I would like a thought from you in terms of how you see the role of regulation and policy within this, and where you think it is not, that's not going to be the answer. But Andrea, you talked about how hard it is to do these ethical guidelines. And the whole emphasis in the Commission's communication is on we need to work on this together, hence the setting up of an alliance, hence the work that you're doing, bringing all of you together from your different disciplines to address this. But it sounds like it's quite tough to get all of you around the table to agree. What do you see as saying we need to work together and join forces and multi-stakeholder is as much as talk, but it's very easy to say and very hard to do. What do you see as the biggest challenge here to really make sure we do join forces to address these issues, from your experience in the group? And then Marco, I want to ask you about the role of policy and regulation in this.
So far, the biggest challenge has been not the idea of identifying what the ethical principles might be. The real challenge is to imagine how you operationalize those principles in reality in the different settings. This is really, because it's like building a new legal system from scratch. Although there's a lot of legislation already in place that would help in this respect, but there's a number of situations that you need to imagine that are very difficult to anticipate. That is the big problematic thing. And the other thing that I see very problematic is that the rhetoric of co-designing, co-creating things works up to a certain level, but the purely bottom-up policy making is very risky. There are many experiments in trying to see what people would consider to be, for example, good principles or good criteria to solve specific situations. The most famous, probably, the moral machine experiment that the MIT has run on the famous trolley problem for self-driving cars. Should a car kill the occupant or a group of people or another group of people in cases in which a collision is inevitable? There's some colleagues of mine have also had a very interesting experiment asking a sample of people what criteria would be acceptable in deciding who should receive a kidney in kidney exchanges. You see that it's very difficult to reach a decision there. You incorporate all the cognitive and the behavioral biases of people. You incorporate a lot of the imperfections of our behavior into the system. And this is very, very complicated. But
then at some point, the top down has to come in, the Marcos, and put some sense on this and make a decision, because you can't always... Marco, how do you see your role as compared with, for example, the work being done by these expert groups?
In a field where national competences are regional competences, and the European Union does.
Indeed.
I think that I want to build on this co-creation approach, because I think that the approach that at least I'm testifying here is also internally in innovation, that there is a strong link between those that are supporting research, those that actually are working with healthcare provisions, DigiSantec, DigiConnect for the digital aspects, to master all these elements. So with a balanced approach, we support research and innovation, but we also look at the challenges from a policy point of view. I'm sorry, some of these regulations are already there. We don't need to reinvent GDPR. No. So we don't need to reinvent the medical device direction. So if it is a medical device, it's a medical device. So where is that we are going to discuss is those aspects, for instance, where it is unclear whether this is a medical device or not, because, for instance, the app is telling me to run 100 kilometers a year or whatever, or do the 10 active as proposed by NHS, which I like more, the 10 minutes rather than the 10,000 steps. But it is there that we will need to. So if you take the privacy framework, which is there, we take the cyber security scheme. You have a directive, which is the national, the NIS. Sorry if I use acronym, but technically there is a directive at European level that does give the possibilities to identify the provisions of services or operator services, including in healthcare, to address the issues of security of data systems used in hospitals, for instance. So there are already frameworks there, and I think that we are progressing, we are connecting dots, and we are progressing. That's why we are very happy because these analyses of the ethical issues, they are done. This is the European approach. So we look at the research, but we also look at the ethical aspects.
Absolutely, absolutely. Any quick comments to the role of policy regulation, and then we're going to draw some conclusions. Martha, did you want to come in?
Adding on regulation, that is currently now is the NIS directive, the Network Information Security Directive. So the network needs to be secure in order the transportation of data is secure too. So and this is a regulation that is in place.
Absolutely. Stefan, any quick points?
No, I think it is important. We all agree on that. It's just if we can speed it all up, that would be good.
Okay, we are almost, speaking of speeding it up, we are almost out of time, and I just wanted to try and identify some priorities. This is a very unfair question because I'm not suggesting, at the beginning Andrea enumerated very well a very complex set of challenges, both for the healthcare sector broadly and then for AI in health sector, and those complex interactions that we've been talking about between all these issues. So I'm in no way by doing this asking for a silver bullet, one thing that's going to make us suddenly instantly be able to say, yes, we're ready, yes, we can seize this full potential. But if for each of you, so maybe I won't put it as a one priority, but as a key next step. One thing we need to do, and it can be for policymakers, it can be for industry, it can be for academics, it can be for practitioners, medical professionals themselves. And one thing we need to do to make sure that, say we were to have this discussion again in a couple of years' time and ask the question, is Europe ready? We would be closer to saying, yes, we are. What would your priority, your key next step be? I'll go straight down the line, starting with Stefan.
Skills, training, education. Postdoc programs, graduate programs, professorships, that would be the next step. We are not having enough people with the right skills.
Thank you very much. Martha?
Adding to this, incentives to innovation as well.
Make sure that they want to do it.
Exactly.
And it goes back to your mandatory thing on how do you get people to recognise and take up this challenge. Marco?
Yeah, sorry, I wanted also to build on this, to create an environment which is conducive to innovation in a way that is lawful as well. So if I had to add something else, which is different, I would steal and I would say trusted data spaces on which we can work.
Thank you very much. You don't have to, you can all agree and just have one priority. It very rarely happens on a panel, but it would show that we have a clear sense of direction. Nicola?
I think it has to be tackling the issues of trust, because if we don't get that right, we won't have license to operate. So the skilled people that have been trained won't be able to do anything because we won't have data about diverse populations. So I think building public confidence, and by public I include clinicians as well as patients in that.
So getting these ethical guidelines right for trustworthy AI will be the very first step. If we don't get that right, we won't bring patients or doctors on board.
What a responsibility.
Yeah, don't feel, no pressure, no pressure. Gustav?
Yes, you asked the question, is Europe ready?
Yeah.
My answer is make Europeans ready. including European doctors.
Yeah.
So what are we teaching now that we shouldn't teach anymore? What are we not teaching that we should teach? And that's a major evolution in the teaching in medical school. I mean, be adapted to the evolution.
So we need a really fundamental re-evaluation of what you're doing.
I mean, literacy in informatics, in Bayesian statistics and so on is as important as has been anatomy, physiology, and biochemistry. So we need a revolution in the teaching in medical schools. That's my...
Thank you very much. Andrea, revolution, evolution, what's your key next step?
My key, let's say, frontier for the next couple of years, and I think it fits well also the European Union policy agenda, is nesting the debate on artificial intelligence in the Sustainable Development Goals.
Yeah.
There is a huge gap of leadership in AI for good. There's only the United Nations that tries to do a little bit of that. But if we do that, we will be asking all these other questions, because the SDG is the way we picture the evolution of our society in the medium term. By 2030, they incorporate human capital, skills, innovation, infrastructure. I mean, have a look at them. The way in which we look at AI through this lens, I think, is the key for understanding how do we use it to our benefit, to the benefit of our society and our prosperity. There's no other way, in my opinion, in which we can get all these questions right.
And on that note, ladies and gentlemen, would you join me in thanking our panel very much indeed for a wonderful, wonderful discussion.
Well, Jackie, thank you very much as well for moderating this so beautifully. I honestly think this has been one of the best forum meetings we've had, and it's due to your very insightful comments all the way across the piece, from industry to regulation to clinical practice to research. I mean, it really is good. It's very good for me to realise that the EU are taking this seriously. You know, if it was just saying, well, computers are there, thanks very much, I'd be very worried. But no, you are taking it seriously, and clearly we are not there yet, but we will be soon. Now, in my practice and so on, I always try to reduce things to the very simplest and then build up that complexity. If we start from the simple phenomena here, medicine as it's practiced at the moment completely depends on computers. Absolutely depends on computers. Gustav, imaging in neurology, what a transformation we've had even in the last 20 years, let alone the last 5 years. I mean, it's remarkable. Data collection and accumulation for patients, and the ability to track for 20 years what's been happening to a patient biochemically. We couldn't do that before. So computers are in use, they will be ascendingly in use. The big difference is that word intelligence. Intelligence to me means the ability to take in information and have a decision. And clinicians take in information from computers, from patients, often with incomplete information, have to make a decision. And that's part of in experience, being intuitive. But nevertheless, it's a binary system. You do something or you don't do it. And computers are helping us to do that already. So if we're talking of artificial intelligence, perhaps we are talking of the evolution of computers actually making a decision for us, rather than us using computers to make a decision. A few years ago, I had quite a difficult discussion with the dean of my medical school. We were becoming over-managed, and management was becoming an endpoint rather than being a medical school. And I said, Peter, don't you think we should get rid of the word management and we should use the word enabling? And that the group at the top, currently called managers, should be called enablers. And they should look at the workforce, the skills, the patients to be enabled to do their job properly. And that's what I think I would love to see AI, and I still think it's the wrong term actually, but it's there and I'm not going to be able to change it. But that's what AI perhaps should be doing in the future. It should be enabling rather than defining itself. And the human parameters of medicine are going to be there forever, because you have to get information from patients. Patients can lie to computers. They can hide things. They can hide things from clinicians. And it's a good clinician who says, now come on, tell me. You don't really do that, do you? You know, I've done it myself. But, I mean, this has opened lots and lots of thought. We could be here for many hours yet. And just to say thank you very much for your fantastic contribution. Thank you.
For organising today. Thank you all for coming and your reward awaits. If you can stay, cocktails will be served in the front room where coffee was served beforehand. I do hope you can join us for a quick drink, and I wish you a very pleasant evening, whatever you're doing. Thank you very much. Thank you again.